Hello everyone, this is Shankar. Hope you are doing well. So, all are known, like I am started the Apache Kafka series of videos. So, it is not a stretch video. In previous video, I have clearly explained about Apache Kafka software, download and install. These are the two old videos. If you want to, you can go through. So, every latest video, it will be stored in this Apache Kafka playlist in bottom. Every latest video will be stored in bottom of this playlist. So this playlist I will provide in description of this video. So as officially this is the second video. So in this video we will discuss about Apache Kafka introduction. Apache Kafka introduction. In this video we will discuss. So next videos onwards we can do some exercises like producer creation, consumer creation, listener, topic, partition, everything we will discuss. So let's get started. So today our topic is Apache Kafka introduction, right? So Apache Kafka. Apache Kafka. What is Apache Kafka? Distributed distributed event streaming platform. Apache Kafka is a distributed event platform. Distributed event streaming platform, right? So tell me what is the Apache Kafka? It is a distributed event streaming platform. So post point. These are the very important points one by one. I will explain. Just we are understanding now introduction about the Apache Kafka. Right? Apache Apache Kafka is an open source is an open source distributed event streaming platform developed developed under the developed under the Apache Software Foundation Apache Software Foundation. So first point, Apache Kafka is an open source distributed event streaming platform developed under the Apache Software Foundation. Apache Software Foundation. It is primarily it is primarily written in Java and Scala. It is primarily written in Java and Scala. Third point, Kafka is designed to handle real-time data streams and build high performance data data pipeline. So Kafka is designed to handle real-time data streams and build high performance data pipeline. So fourth point, Kafka is used to transfer and integrate data between multiple distributed systems and applications. Kafka is used to transfer and integrate data between multiple distributed systems and applications. So, fifth point, Kafka. Kafka follows a publish-subscribe messaging model for exchange data between applications, comma, services, comma, and servers. So, Kafka follows a publish-subscribe messaging model for exchange data between applications, services, and servers. Kafka was originally developed by LinkedIn LinkedIn in 2010 and was later was later donated donated to the Apache Software Apache Software Foundation. 7 point, Kafka was originally developed by LinkedIn in 2010 and was later donated to the Apache Software Foundation. Seventh one, Kafka became an Apache top level top level project in 2011. Kafka became an Apache top level project in 2011. So, 8 point, Kafka is widely used as a modern alternative to traditional message brokers. Traditional message brokers. So here, traditional messaging systems are not like ActiveMQ. It is old one. Traditional means old. So Kafka is widely used as a modern alternative to traditional message brokers. So 9 point. So Kafka provides Kafka provides reliable, comma, high throughput, high throughput, comma, and low latency communication between producers and consumers. So Kafka provides reliable, comma, high throughput and low latency communication between producer and consumer. Producer and consumer. Kafka enables continuous real-time data streaming, real-time data streaming between applications. See, Kafka enables continuous real-time data streaming between applications. That means it is continuous data flow between two applications. So 11, Kafka is designed for designed to be Kafka is designed to be horizontal horizontally, horizontally scalable, so distributed, fault tolerant, so horizontally scalable, distributed, fault tolerant, high available, high available, high available. So 16 point Kafka is commonly used in event event driven event driven event driven architecture. So event driven architecture, EDA, where microservices publish and subscribe to events. So Kafka is commonly used in event-driven architecture, EDA, where microservices publish and subscribe to events. Publish and subscribe to events. Seventh point, Kafka stores data in topics and distribute distributes distributes data across multiple partitions for scalability. See, so Kafka stores data in topics and distributes data across multiple partitions, multiple multiple partitions for scalability. Right? 18th point. Kafka Kafka supports data retention, retention, allowing allowing message to be message to be replayed replayed even after consumption, even after consumption. So that means I will write here. So Kafka support data retention, allowing messages to be replayed even after consumption. So here that means Kafka Kafka supports data retention, which means messages are not deleted immediately after consumers read them so after consumers read them, right? So 19 point here I will repeat one more time. 18 point, it is very very important. So like Kafka supports Kafka supports retention. Data retention. What is that data retention policy? Nothing but so producer sending messages to consumer, right? Producer sending messages to topic. In the topic, it will be stored. After that, consumer consumes it. Due to consumer is so consuming message from the multiple topics. So it is due to the heavy. So it is taking some time, right? Some lag will be happen. So if that lag is reached to 7 days, then it is called like data retention nothing but messages will be stored in topic until 7 days. So retention policy, retention policy nothing but messages stored until 7 days. 7 days. This is the one condition or size. So messages store somewhere messages will be stored, right? 1 GB until 1 GB. So either this 7 days will be completed or size reached to 1 GB. So it will be deleted from the topic. It is nothing but data retention. It is nothing but data retention. So 19 point Kafka uses a cluster architecture. Kafka uses a cluster architecture consisting consisting of broker to ensure reliability, reliability and fault tolerant, reliability and fault tolerant. Kafka uses a cluster architecture consisting of brokers to ensure reliability and fault tolerant, reliability and fault tolerant. So these are the major points. So I will repeat once before I will increase the size. So yeah, it's fine. I will repeat these all points. These are the very, very important. After that, we will discuss about types of messaging systems. Like here also I mentioned like publish subscribe messaging. It is the one type. And point to point messaging is the another type. So one by one we will discuss, right? So today we are discussing about Apache Kafka introduction. Apache Kafka. What is Apache Kafka? Distributed event streaming platform. So Apache Kafka is an open source, free to use, distributed event streaming platform developed under the Apache Software Foundation. So Apache Kafka is developed by the Apache Software Foundation, right? Second one, it is primarily written in Java and Scala. So it is developed by using Java and Scala programming, right? So third point, Kafka is designed to handle real-time data streams and build high-performance data pipeline. So Kafka is designed for handling the real-time data streams, right? After that, fourth point, Kafka is used to transfer and integrate data between multiple distributed systems and applications. So Kafka we can able to integrate multiple systems. So mostly Kafka is it for the data transfer, right? So Kafka follows a publish subscribe model. Kafka follows a publish subscribe messaging model for exchange data between applications or servers or applications, services or servers. So see, Kafka follows a publish subscribe messaging model for exchange data between applications, services and servers. So sixth point, Kafka was originally developed by LinkedIn in 2010 and was later donated to the Apache Software Foundation. So Kafka became an Apache top level project in 2011. So Kafka was widely used as a modern alternative to traditional messaging brokers. Nothing but it is the latest one compared to the Act2MQ. So Kafka provides reliable, high throughput and low latency communication between producers and consumers. So in Kafka we have the producers, consumers, they right? Producers. So producer is a publisher, consumer is a consumer, right? So we are sending messages from producer, consumer is listening. In between, cluster will be there, topics will be there, partitions will be there, etc. will be there. Those we will discuss in later videos. So Kafka enables continuous real-time data streaming between applications, data streaming between applications. So data streaming between applications, right? Next, Kafka is designed to be horizontal, scalable, distributed, fault tolerant, high available. These are the important. So Kafka enables continuous real-time data streaming between applications. Kafka is designed to be horizontal scaling, distributed, fault tolerant, high available. So Kafka is commonly used in event-driven architecture (EDA), where microservices publish and subscribe to events. So 7 point, Kafka stores data in topics. See, where Kafka will be stored data in topics like producer application will be there, consumer application will be there. Between the topics are there. Some Kafka architecture will be there between the producer. Producer is a Java application. Consumer is a Java application between the two applications. So what will be there? Kafka will be there. Suppose single application only. So in single application from one place it is producing the messages, in another place consuming the messages. Right? Kafka stores data in topics and distributes data across multiple partitions for scalability. So next, Kafka supports data retention, allowing messages to be replayed even after consumption. That means so some data retention policy will be there. Nothing but so in Kafka in topics storage, Kafka messages will be there for the 7 days or until reach the 1 GB. If it is reached 1 GB or 7 days it will be completed, those messages will be auto deleted. Like that, configurations are set in in config slash server dot properties file, property server dot properties file will be there, right? In that, some configurations will be there. So Kafka supports data retention, which means messages are not deleted immediately after consumers read them. So it will not delete immediately. Once it is data retention policy is expired, then only it will be deleted. Right? So next point, Kafka uses a cluster architecture consisting of brokers to ensure reliability and fault tolerant. So so suppose let's try to design one architecture. This is rough architecture. This is not the same. This is a producer. Producer application. Assume this is a consumer application. Assume this is a Kafka architecture. What is saying up to what we understand. Suppose assume this is a cluster. So it is a cluster. What will be there? Inside clusters, brokers will be there. Assume broker 1, broker 2. This is the B1, broker 1. This is the broker 2. Inside broker 1, broker what will be there? Topics will be there. Topics, right? Topics will be there. For scalability, what will happen? Topics will be divided into partisans. Then partisans will be there. And records, so many are there. Assume this is like a high level architecture. Assume right now, assume this is like a high level architecture. We will discuss later. So these are the important points. So we will recall again quickly. So Apache Kafka distributed event streaming platform, right? Apache Kafka is an open source distributed event streaming platform developed under the Apache Software Foundation. It is primarily written in Java and Scala. Kafka is designed to handle real-time data streams and build high-performance data pipelines. Here, pipelines. Kafka is used to transfer and integrate data between multiple distributed applications and multiple distributed systems and applications, right? See, Kafka is used to transfer and integrate data between multiple distributed systems and applications. Fifth point, Kafka follows a publish subscribe messaging model for exchange data between applications, services, and servers. Kafka was Kafka was originally developed by LinkedIn in 2010 and was later donated to the Apache Software Foundation. So, Kafka became an Apache top-level project in 2011. Kafka is widely used as a modern alternative to traditional message brokers. That means Active is the traditional one. So, Kafka provides reliable, high tolerant, and low latency communication between producers and consumers. Kafka enables continuous real-time data streaming between applications. Kafka is designed to be horizontally scaling, so distributed, fault-tolerant, high available. Kafka is commonly used in event-driven event-driven architecture (EDA), where microservices publish and subscribe to events. So Kafka stores data in topics and distributes data across multiple partitions for scalability. Kafka supports data retention, allowing messages to be replayed after event. So messages to be replayed even after consumption. So Kafka supports data retention, which means messages are not deleted immediately after consumers read them. See here, replace even after consumption. That means so one consumer is consumed the message. One one message will be consumed. After that, that consumer will be crashed. So data is available in the topic. Then what it will do after it will working fine that consumer it is again try to consume it. That is nothing but replayed even after consumption. Kafka uses a cluster architecture consisting of brokers. So cluster consisting of multiple brokers to ensure fault tolerant reliability and fault tolerant, right? So 20 point here up to these are the points here. I will discuss about types of messaging systems. Now adding a types of messaging messaging systems. It is very important. So red color. Let's increase size to 24. Types of messaging systems. So this size is 20, right? So now it is two types of messaging systems are there. So black color side 20. So post one, point to point to point, point to point messaging system, point to point messaging system. So here point to point messaging system. Second one, second one, publish, publish, subscribe, messaging, messaging system, messaging system. Decrease the size to 20. So these are the two types. Point to point messaging system. Let's change color to this also. Let's change color to here. So I will give definition and example. Both to definition, definition, example. After definition, I will draw a diagram. After that example, I will give. So let's add some points. Yeah. So messages like one to one. Point to point means one to one. Messages. Messages are stored in a queue. In a queue. One to one manner. Right? Second one. Each stored. Each each message can be consumed by only one consumer. Third one. Once a message is successfully consumed, but the once a message is successfully consumed, what will happen? It is removed, removed from the queue, removed from the queue. Fourth point, multiple consumers can multiple consumers can process messages, but each message each message is delivered to only only one consumer, right? So these are the points are important. Let's understand definition. Point to point, like a active MQ. So messages are stored in a queue. Each message can be consumed by only one consumer. Once a message is successfully consumed, it is removed from the queue. So multiple consumers can process messages, but multiple consumers can process messages, but each message is delivered. Each message is each message is delivered to only one consumer, right? So here I will add a diagram. So first let's draw a diagram. Let's use the paint for that. Quickly I will draw a sample diagram for point to point system. So for point to point system, point to point system. So it is a point to point system. Select, increase the size to some more height. Point to point system, right? So what is the point-to-point system? Let's add some boxes. Suppose it is a producer, publisher. Assume this is a publisher. So after that, assume this is a message. Publisher sends a message. It will be assume this will be queue. So it is a consumer. Consumer means so assume consumer means client, consumer or consumer. So like it is a publisher. So it is a publisher. Publisher will publishes messages to the topic, right? So sends. Publisher what will do? Sends. What it will send in point to point. There is no topic concept. So queue. You can assume queue. So message. So publisher sends or sends message to where queue. It is the queue. Send messages to queue. So after that, so yeah, this is a consumer. Consumer work is consuming the messages, right? So yeah, that's it. Now arrow marks. This is two direction will be there. Consuming. After that, it will return the acknowledgement, right? It will return the acknowledgement. So now this is sending and it is returning the acknowledgement. So acknowledgement. Now, so message receives. So message receives here message receiving from queue, message receiving to consumer. What will do consumer? It will return acknowledgement. ACKNOWLEDGES. Acknowledges, right? It will send the acknowledgement. So here it will be like this arrow mark. Publisher publishes the message. So after that, it will sends to the queue. Once messages are reached to queue, what will happen here? Consumer consume the messages. Once messages are reached to queue, consumer consume the messages. So point to point system. It is a point to point system. Here there is no concept like topics like that. It will be queues will be there. Point to point system. Publisher sends messages to queue. Queue what it will do? Queue from queue consumer consume the messages. Once successfully consumed, you will send a acknowledges or acknowledgement kind of. So let's copy this. Control C. Let's add in Word document here. So yes. After that, let's add another some points. So some another points. So like so messages messages are persisted. Messages are persisted in a queue. In a queue. But but a particular but a particular message can be consumed by a maximum of one consumer only. One consumer only. That this means Messages are persisted in queue. So messages are now reached to queue, but a particular message can be consumed by a maximum of one consumer only. So in point-to-point system, only one consumer can consume the message, right? Second point, once a once a consumer reads a message, reads a message in the queue. In the queue, it disappear disappears from that queue. So it will be removed from that queue, right? So these are the two important. Messages are persisted in queue, but a particular message can be consumed by a maximum of one consumer only. So once a consumer reads a message in the queue, it disappears from that list. So now example, let's say add an example here. So example here, see, order order processing system. Suppose order processing system. Let's take order processing system. For example purpose, I am taking the order processing system, right? So multiple multiple order processed multiple order processors may exist may exist. Each order is each order is processed by only one producer, only one one processor one processor. See example, order processing system. So order processing system. So green color example, order processing system. Multiple order processors order processors may exist. Each order is processed by only one processor, right? So point to point messaging is done. Now publish subscriber messaging system. So let's add a point before point. It is the definition, right? Post definition. So we are following pattern like post will be definition, right? So inside definition, some bullet point, not here, here. So messages are stored stored in a topic. So see here, in point to point messaging system, there is no concept of topic. So if some interview may ask like in active MQ where topics are available, it is a invalid question. So don't think like interviewers always ask valid questions. They may be ask invalid questions also. Then you can say it is the invalid question like that. So messages are stored in a topic, right? So multiple multiple consumers can subscribe to the same topic. See, multiple consumers in above point to point, only one consumer. One message equal to here in previously point to point. So one message equal to one consumer. But here one message equal to multiple consumers. So understand, right? Multiple consumers can subscribe to the same topic. Third one, each each subscriber each subscriber receives messages messages from from the topic, on its on its subscription. You may confuse like here subscriber. What is subscriber? Consumer, subscriber, both are same. Producer, producers, both are same. So each subscriber receives each subscriber receives messages from the topic from the topic. So each subscriber receives messages from the topic topic based based on its subscription based on its subscription. Producer producers producers or producers are called producers are called producers are called publishers publishers, right? Consumers are called subscribers are called subscribers. So the definition: messages are stored in a topic. Publish subscriber messaging system. Topics will be there. Those messages are stored in the so in topic message stored will be there. There it will be stored. Multiple consumers can subscribe to the same topic. Each subscriber receives messages from the topic based on its subscription. Producers are called publishers. Consumers 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 are called subscribers. Consumers are called here. Consumers are called subscribers. So let's develop a diagram. So after that, some example. Then we will wind up this video. So I need to remove everything. Control X. So now publish subscribe. Publish hyphen. Publish hyphen. Subscribe. Publish hyphen. Subscribe system. So I need to change size to 45 like that. 48. Publish subscribe system. So post producer will be there. Message will be there. Message publishes to the topic. Publishes to the topic. So that message may be consumer like subscribe to multiple consumers. So now it is the publisher. It is the publisher. So publisher or producer. Publisher. Suppose publisher. What it will do? Publishes. What publishes? Message. Message it will be published. Where message it will publish? Topic. Topic. After that, what will happen? Message. So multiple consumers will be subscribe. Suppose consumer one, consu, consumer one. It is consuming the message. This is the consumer. This is the consumer two. It is also consuming the message. So let's say add a arrow mark first. Publisher publishes message. Where it will be published. So I will tell publishers to topic. So in top of the topic, so many are there. Like brokers will be there. Brokers top of that, like cluster will be there. I am not mentioning all those. We will discuss those separately. So consuming. So consuming messages. Here also consuming messages. See, this is the consumer one. This is the consumer two. So here subscribers. So what will happen here? Let's add another arrow mark. Let's add other arrow mark. So some other arrow mark. First, what will happen here? Decrease the size to 26. So here subscribe, subscribes, sub subscribes. So it will be subscribed. Consumer one message subscribed. What will happen? Delivers topic. It will deliver the message. Subscribe, subscribes, delivers. Same here. Consumer to subscribes. Consumer to subscribes. So then it will deliver the message. Daily delivers. Delivers. So it is all about point to point system. It is high level, very high level. So later videos I will go in depth. Go in depth about. So this here, right? After that, so after that, some points. So let's add. So after that, some points. So now messages are messages are persisted persisted in a topic. See above messages are persisted in a queue. See messages are persisted in a queue, but in point to point queue will be there. In public subscriber topic will be there. Messages are persisted in a topic. In a topic, right? Comma unlike point to point, unlike point to point, point to point, point to point system, right? Consumer consumers can subscribe to one or more topic, and consumer 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 all the consume all the messages in that topic, in that topic, in the publish hyphen subscribe, in the publish hyphen subscribe system messages producers messages producers are called publishers, and message consumers are called subscribers. So see, messages are persisted in a topic, unlike point-to-point system. In point-to-point system, messages are stored in the queue. So after that, consumers can consumers can subscribe. So subscribe consumers can subscribe one or more topic. One topic is there. Consumer or multiple consumers can subscribe or multiple topics are there. One consumer or multiple consumers can subscribe. So and consumer all messages in the topic in the consumes all the all the messages in the topic. So in the publish subscribe in the publish subscribe so subscribe in the publish subscribe system messages in the publish subscribe system message in the publish message in the publish subscribe system message producers are called publishers and message consumers are called subscribers, right? So now I need to explain about one example, then this introduction will be completed. So for that, so example this TV subscription, Netflix subscription, these are the best examples. So this TV, this TV publishes this TV publishes channels channels such as sports, movies, music, etc. Multiple are there, right? So users users subscribe to their preferred channels channels and receive content accordingly accordingly so receive content accordingly, right? So okay, let's revision the types of messaging systems. Let's revision the types of messaging systems. So let's revision the types of messaging systems. So So, types of messaging systems. There are two types there, right? Point to point messaging system and publish subscribe messaging system. Point to point in queue will be there. So, publish subscribe topic will be there, right? This is major difference. The architecture or so many differences are there. We will discuss definition. Point to point messaging system. Messages are stored in a queue. Each message can be consumed by only one consumer. In point-to-point messaging system, one message is equal to one consumer. But public subscriber system, one message is equal to multiple consumers. Once a message is successfully consumed, it is removed from the queue. Here, once it is consumed, it will be removed. But in public subscribe, there is called a retention policy. 7 days will be there. Or once capacity limit is reached, it will be removed like 1 GB. Multiple consumers can process messages, but each message is delivered to only one consumer. So this is the diagram. Publisher, producer sends messages to queue. So one consumer, one message equal to one consumer will be consumed. Once successfully consumed, it will send acknowledgement. So messages are persistent in a queue, but a particular message can be consumed by a maximum of one consumer only. Once a consumer reads a message in the queue, it disappears from that queue. So, for example, order processing system. Multiple multiple order processors may exist. Each order is processed by only one processor. So, next one, publish subscribe messaging system. So definition, messages are stored in a topic. Multiple consumers multiple consumers can subscribe to the same topic. So like one topic is there that contains some data or some message. Multiple consumers will be consumed in point to point. One message equal to one consumer, but in public subscribe, one message equal to multiple consumers. And your topic will be there will be queue. So each subscriber receives messages from the topic based on its subscription. Producers are called publishers. Consumers are called subscribers, right? Publish subscribe system. Producer publishes messages to topic. So consumer subscribes, right? So messages are persisted in a topic. Unlike point-to-point systems, consumers can subscribe to one or more topic and consume all the messages in the topic. So i- in the so in the publish subscribe system, messages publishers are called publishers, message producers are called publishers, and message consumers are called subscribers. Example, Dish TV publishes channels such as sports, movies, music, etc. User subscribe to their preferred channels and receives content accordingly. So for point to point, what is the example I chosen? For point to point order processing system. So for point to point, I choose an example like order processing system. For public subscribe, I chosen like so this TV. So there are some benefits are there, key benefits of Apache Kafka. After that, what are the topics left? Still I am not covered. Those I will mention. So key key benefits of Apache Kafka. So key benefits of Apache Kafka. These are the very important. So let's red color. High throughput. High throughput. So let's remove this one. Let's add a numbers. Let's add a number. So let's add a number. Let's add a dot. Otherwise, so yeah. Now key benefits of Apache Kafka. I I throughput. I throughput. After that, real time data processing. Real time data. Real time data processing. Fault tolerant. So fault tolerant. Fourth one, scalability. Scalability. Fifth one, durability. Sixth one, distributed architecture. Distributed architecture. So event streaming. After that, message retention. After that, decoupled communication between decoupled communication between systems. So next one, support for microservices architecture. So let's revision these key benefits of Apache Kafka. Key benefits of Apache Kafka. I throughput, real-time data processing, fault tolerant, scalability, durability, distributed architecture, event streaming. message retention, decoupled communication between decoupled communication between decoupled communication between systems systems support for microservices architecture. So now next, what else left? So what else left? So like Apache Kafka architecture related, those are left. I will just add those points. Then one by one, those we need to discuss. There are too much depth also there. We need to discuss. Producer, like code, everything we need to discuss here for this. So now producer, consumer, producer, consumer, we need to discuss. Producer, consumer, broker. So topic we need to discuss. Topic divisions also there. Partition, partition we need to discuss. Partitions also, divisions also there. We need to discuss. After that, offset we need to discuss. Offset we need to discuss. So consumer consumer group we need to discuss. After that, record will be there. We need to discuss. Cluster will be there. We need to discuss. What is the cluster? What is the cluster idea? How it will be used? Care after. Care after from 4.x version. We need to discuss 4 apt. So K care apt. We need to discuss care apt. So what are the changes in architecture after that care apt? About care apt architecture. We need to discuss care apt architecture. So what else pending? Replication factor. What is the replication factor? So replication replication factor. What else is there? Like later, which later? Like later and follower, follower. So like maybe some other also missing. So these internals, these all are about internals. These all are about the Kafka architecture internals. These are the pending. Some more also there. So those also we will included one by one. Further videos we will discuss. So right, in next video I will show how to write a producer application. What are the classes are used? What are the methods are used? We need to add it serialization, deserialization properties. What is the bootstrap server? So what is the Kafka port like 9092, etc. All we will discuss. So in this video, we are successfully understand about Apache Kafka introduction. Thank you for watching. For more videos, please subscribe to this.